So the easiest way to approach a problem like this one, because it's given in factors, is you're going to look to cancel any common factors first. Okay? So if I go through here and cancel my x plus 4s, cancel 8x minus 5, cancels with one of these. Now I'm going to look at what remains. Okay? So what remains here is negative 5x in the numerator and 8x minus 5 in the denominator. So when I look at it in this form, I can see a few things regarding the horizontal asymptote. Okay? How do the degrees of the numerator and denominator compare? They're the same, right? So that means, is there a horizontal asymptote? Yes. If they're the same, it's the ratio of their coefficients, right? So now it's easier to see the leading coefficient here is y equals a negative 5 over 8. Okay? And so that would be your horizontal asymptote. And that way you don't have to type all of these into your function or into your calculator. And now when you move to vertical asymptotes exist anywhere you still see a factor in the denominator that has an x. What value of x would give you a 0 for this factor? It's the opposite of my constant. So there is a vertical asymptote. The opposite of negative 5 is positive 5 over my leading coefficient, which is 8. Okay. The holes exist anywhere a factor got completely canceled from your denominator. So we see here's a factor that did get canceled from the denominator. So that's going to be the location of our hole. So there is a hole, and it's located at what value of x would give you a 0 for that factor. On this one, you're not setting it as an equation. You're just identifying the coordinate, the x coordinate of that hole. Okay, and then finally, slant asymptote. This slant asymptote is only going to exist if the degree of the numerator was higher than the degree of the denominator. Is that the case here? No, so there is none. So you could write does not exist. And now when you look for your x and y intercepts, if you come back up to this form right here, if we take this simplified form and we evaluate it for 0, so we get negative 5 times 0 over 8 times 0 minus 5. 0 divided by negative 5 is 0. So our y-intercept, when x is 0, our y is also 0. And we can find our x-intercepts by taking any remaining factors in our numerator, setting those equal to 0. So if we took negative 5x equals 0 and solve, x is 0, that gives us our x-intercept, which also happens to be just 0, 0. All right, so first thing is to find any horizontal asymptotes. So when you look at this, we count the power in the numerator. So we have a degree, bless you, of 2 plus 1 plus 1. So there's a degree of 4 in the numerator. Here we have 2 plus 1, a degree of 3 in the denominator. And remember, you're counting every power of x. So here's 1, 2, plus another 2 is the 4. This one is squared, so that's 2 plus another one is 3. Okay, can you use long division on this? Can you divide a power of 3 into a power of 4? Yeah. So this is the one where there is no horizontal asymptote. Instead, there's going to be a slant asymptote. So let's go ahead and find that first. So to find our slant asymptote, we're going to take and expand, F2 Algebra tab, option 3. We're going to take our whole numerator. Okay, so here I'm going to type 4x squared times x minus 7 times 5x minus 3. So there's my numerator. I'm going to divide by, and in my denominator, I'm going to put the entire thing in its own set of parentheses. So I have the outer parentheses plus my next factor, 5x minus 3 squared over, or times x minus 7. And then close off that whole denominator, and then I'm going to close off my whole expand. Okay, once I do that, I get my answer. And so what I see right here is I see 4/5 x plus 12 over 25. Okay, and so this is going to be the equation for my slant asymptote. So I'm going to go ahead and write that. My slant asymptote is y equals 4/5 x plus 12 over 25. Okay, and so that was found by doing long division. I'm now going to look for my vertical asymptotes in wholes. So this is already in factored form. So I'm going to look to cancel any common factors. So 5x minus 3 cancels with one of these. The x minus 7s cancel here. Okay, so when I look at the result of this, do I see any factors that didn't get canceled from the denominator? Yeah, the 5x minus 3, right? Even though it did cancel with one of the factors, it didn't get completely removed. So this is going to give me my vertical asymptotes. So I have a vertical asymptote of what value of x would give me a 0 for this factor? It's going to be the opposite of the constant divided by the leading coefficient. So the opposite of negative 3 is positive 3 divided by my leading coefficient. So I get 3/5. X equals 3/5 is my vertical asymptote. And then the wholes exist anywhere the factors got completely removed. So the factor, that, even though this factor canceled, it didn't get completely removed, but the x minus 7 did. What 0 is associated with the x minus 7? An x value of 7. So that is where the whole's located. And then finally, my x and y intercepts. The way that you can find the x and y intercept, again, is look at my simplified equation here, which is 4x squared over 5x minus 3. Again, the only value of x that gives me a 0 in the numerator is 0. So that's my x-intercept. Okay, and it's also my y-intercept. Again, when you plug in a 0 for y here, you get 0 over negative 3, which is 0.